Hello guys, hope everybody's doing good on this hot afternoon, about 94 degrees here. And in this video I want to do a little talk about scopes, because I got something special in just a moment that we'll be unboxing, but we'll get that in a minute. But back to the subject of scopes. Scope, you know, is a great handy piece of equipment to have on any tech's bench. In fact, it's a must. It is something you really need to have. And over the years I have acquired several scopes. Remember the new Rogall we got back not long ago, thanks to Neil, the DS1054Z. And if you remember last year I picked up this TAS scope, and you know, it's a 465. And basically what TAS stands for is Tektronix analog scope. It has a little bit of data acquisition on the front end, but it's basically an analog scope, and it has some menu driven features. And I like the scope, but it's, you know, a little bit dodgy. Back when the scope was made, it was made from about 92 to 93. Excuse me, it was made from 92 to 96, and it just didn't take off. Cause about this time Tektronix was coming out with a lot better stuff that just kind of put this scope on the back burner. But it's not a bad scope from what it is, you know. It's a good, reliable scope, but it still wasn't what I wanted, you know. And we have several more in here, just right here on this bench. You know, not only do we have the TAS 465 and the DS 1054Z, we also have the Tektronix 2235 sitting up there, and over there with the old CB analyzer we have a Hitachi 20 megahertz oscilloscope, and it works real good. Remember, that was sent in by Dale last year, and it works good with that system when I do use it. I don't work on a lot of CBs, I just don't have the time for it, you know. So I dedicated that scope to the B&K CB analyzers. Then when we slip over here to the other side of the bench where the older test equipment is, you see up here we have the old ICO oscilloscope, and just over to the left of it is a Bell & Howell. Now there are two oscilloscopes I have always wanted, and one of them was the Syncor CS61, and I acquired this quite a few years ago, and it's a great working scope, 60 megahertz, and it just works fine with RF equipment, you know, on the HF frequency. It's not very good for anything above HF, but it works great for that. That scope has developed a problem, that's why it's sitting up there as a shelf queen. Just haven't been able to get to it to get it fixed, but it's on the list to be done. So we're going to probably be getting a video out on troubleshooting that and fixing it. Sitting over here is one of the first DSO scopes I ever bought, and that was the 01 PDS 6062S, and it's also a 60 megahertz scope. But I never liked this scope from the beginning. When I got it in, it's just, the display is not bright enough to really see what's going on. You can't look at the waveforms and tell. Now it does have a good link to a computer where you can capture the waveforms on a computer, but you know, that's pretty much useless. I haven't made my mind up what I'm going to do with this scope yet. You know, there's $400 sitting there, and it probably haven't got 20 hours of use on it, because I just don't like it. I don't like the contrast and the brightness of the display. I haven't really made my mind up on what I'm going to do with it yet. I might end up just giving it away. I don't know. We'll see how that goes. But you know, sitting over here is another Tektronix 2235 that's used over here on this side of the bench. So I'm sitting here talking about all the scopes I have. Well, you know, I like scopes. I love to collect scopes. I got 8 or 9 more packed away of different various vintage scopes that I haven't gotten around to work on, but will be sometime. And you know, I just love collecting scopes, and I love having scopes on the bench. But the real reason was, like I said, there was 2 oscilloscopes that I've always wanted. One was the Syncor CS61, and the other one is down here in this great big huge box. So we're going to get this thing opened up and let you see what we have in here. Now, this was sent in by a viewer that wishes to remain anonymous, and I'll respect that and will not give out his name, but he took the time and sent this in to us and gave it to us. So let's take it out and see what we have. Now, as you can see, this thing is very well packed. It's put in a big box with a lot of packing peanuts. I mostly try not to use a lot of packing peanuts. I used to try to use the foam now, since Mike has introduced that to me. But when you send out something that's heavy and use packing peanuts, if you don't get it packed right, these things will crush, and then your box inside just goes moving all around. This one's packed right. It's got a big enough box to hold enough packing peanuts to keep the smaller box from bouncing around and crushing them so bad. So we'll go ahead and get the other box out. Alright, we got the smaller box out, which is still a rather large box. So I'm going to go ahead and get this open. I ain't going to bore you with taking the stuff out of the box, but I can tell you it's packed pretty good. Well, I got the big old beast out of that box, and you can see that it's green. Now I got to get the cover off of it. I think y'all be very excited to see what this is. Some of you might even be just looking at this and already know what it is. So let me go ahead and get this plastic off and the covering off the front of it. Now you can see that it is padded on both sides, on each end of it, and that keeps it from getting damaged. It really makes me happy to see that people have enough pride when they ship stuff that they pack it well so it cannot get damaged. And I'm going to tell you, these couriers, some of them, they don't care what's in the box. They just toss it on the conveyor, toss it in the back of the truck, and end up tossing it on your front doorstep. So let me go ahead and get this off. So what was in the box? Well, as you can see, it's a Tektronix 465 2-channel 100 megahertz oscilloscope. Now, this Tektronix 465 is probably one of the most popular oscilloscopes that's ever been made by Tektronix. These things has graced many repair benches across the country. A lot of people love these things. I have been trying to get one for years off an eBay that was, you know, a tech special, and I always get beat out on it. So thanks to our anonymous friend for sending this in to us and giving us a chance to get this old great piece of history back up and running. Now, when this thing is fixed, it will probably be one of my main oscilloscopes while working on tube equipment. I do not like putting the TAS 465 or the Rigol on tube equipment. It seems to like solid state stuff better. But this old 465 will have no problem working on tube receivers and transceivers or transmitters. So you can see it's in very, very nice condition. It just looks real good. I don't even have to do much cleaning. There is a cow sticker on it. Let's see what the date is. And it looks like the date of calibration was 12 April of 88. And it was supposed to be recalibrated on 12 April of 89. So yeah, we have a calibration sticker. Scope is in really nice shape. You know, it's got a few battle scars on it, but that's expected. One surprising thing is to still find the bag on top is still in good shape. It's not torn up or anything. And inside we have the original Tektronix instruction manual. Let's see what else is in here. Oscilloscope probe kit paper. There was no probes with this. And we have this part. And if you're not sure what this is, which these are probably rare and hard to find itself, but let me show you. You're using this scope outside, like at a tower or something, working on a piece of equipment outside, you just pop this over the top. This gives you a bezel around your screen to keep the sunlight off of it, so you can see the waveform better. Very nice. Let's stick that right back in the pouch. Have a look at the back of it. I have a mains power cable. Still has the protection plug on it. Back looks real good. No signs of any damage whatsoever. The rubber feet on the back for standing it straight up are missing. And one thing I liked about what this guy did, which was very professional of him, was that he sent this envelope. He also sent parts that he's replaced inside of it. And not only that, he sent a very comprehensive letter of the things that he found that was giving it problems and what he'd done to try to correct it. And it looks like to me from reading this just a moment ago that the problem is in the power supply. Has a lot of ripple on the power supply. He replaced capacitors. Something happened, it did not want to work. He went back, put some of the old capacitors back in, got part of it back up and running, but it had a 60 cycle ripple on the waveform to start with. So, you know, he did the right thing by going to the power supply. He also had no sweep. He found a part in there that was bad. He replaced that, got the sweep back going. So, looks like we got something here that's going to be fun to go through to figure out what was going on with it. So what is our next step to do on this? We've got the scope sitting here. Maybe we need to turn it on and not take it apart. No, we're not going to do that, because thanks to our anonymous friend, he gave us enough information already in the letter that he sent with it that we know that we don't even need to turn it on and try anything. Probably best just to go ahead and take the scope apart and let's see what we can find out that's going on with it. Okay, I'll remove the screws from the back of it and pour the rear bezel off. So all we should be able to do is push the scope right on out the front. Yep. bit tight there. And there it goes. Just have to lift up on the back just a little bit. And just slide the cover right off. And there's the inside of the scope. Now, one of the nicest things about working on this type of Tektronix oscilloscope, just about all of your major semiconductors, your transistors, and your ICs are socketed. So it's real easy to test by just pulling the transistor out, testing it, and putting it back in. No soldering required. Now you will see some transistors are soldered in, but mostly, you know, those are not in no critical areas, but just about everything that's critical will be able to unplug and check. Now Tektronix do have a few items in this that they roll themselves and would probably be impossible to find if you need it. But from reading the documentation that the viewer sent with this, I don't think that would be any problem at all with this oscilloscope. So I think mostly what we need to do is just go through this power supply board back here. You can see the cap still standing up here, and check out this power supply and get that power supply back up and going like it's supposed to. Now, one thing I have found, I have worked on quite a few of these over the years, and one of the things I have found that has caused a lot of problems, you'll see there's two big transistors mounted here on the case, and I have seen these legs break and cause issues. But that doesn't appear to be the problem with this particular scope. Now your regulators, these bridge rectifiers, are soldered in. They will not be plugged in. So we'll need to go through all these bridge rectifiers and make sure that they're right. Check all the voltages on the low voltage supply. I finally have a high voltage probe coming that's good to up to about 80,000 volts. I talked with the guy this weekend. I've made him offer on the whole kit. He has a Fluke 27 FM, which is the military spec voltmeter, and I've looked on eBay to see what they're going for, and I think we've come up with an agreement, so I will be purchasing that from him, mainly for the that nice 80,000 volt high voltage probe that it has. And I guess you can say the old 27/FM is just being thrown in for it, and it's in a case, and it's got the original probes with it too. But very nice looking low hour unit. So I was hoping to get it this week, but it'll probably be 2 weeks from now before I get it. But it'll be nice to have. Another thing I've always liked about the way Tektronix did this is your power switch here on the front. You can see this rod runs back to this little connector here on the back, and you see that's just a simple toggle switch in there, and that is your power button. Now this is drilled out for another switch to be put in, and I'm not sure if this is something that was done on a different model or carried over from a model onto this one. But I've always really liked the way that Tektronix did this mechanical switching on stuff. Even the some of the switches on the front. Let's see if I can find them here. Let me zoom them out a little bit. There they are. You can see these flip switches on the front. Has these little rods that go down to the switches. Very ingenious the way that they did stuff like this. I was just looking over the thing here and see the front end for channel 1 and channel 2. See our delay line coming in back here in the back, and it goes into the middle and just spirals around. I'm not sure quite how long that delay line is, but you know, that's a little bit of I guess what you can call data acquisition on that delay line. A few milliseconds, I think, what it is. But yeah, I'm telling you, it's just amazing that just how clean the inside of this unit is. It looks very nice. You know, and as always, the good thing about the way that this unit is designed, it's very simple to service. You don't have to pull a lot of stuff out just to get in here and work on it. Looks like, you know, the power supply is right behind this board, and everything is soldered on the main board from the bottom side. The only thing is getting to some of these bridge rectifiers from this side is, you know, practically impossible without removing the board or removing stuff. But if you take your time, use a good iron, you can actually remove the components from the bottom of the unit without getting to the other side of the board to desolder it. So there we go, a quick look at a classic Tektronix 465 oscilloscope. I think we'll get some good series out of this piece of equipment. We're going to start with the power supply and work our way through that and make sure the power supply is working correctly and there's no other problems in that. Then we'll move on to the vertical and horizontal amplifiers and check all them out. Make sure everything's good, give everything a good cleaning for switches and stuff, and get this old girl back up and running like she used to be. So again, big thank you to our anonymous viewer for sending this in. It's a wonderful looking piece of equipment. We're going to have a great time getting this up and running, and will be a very nice access to the workbench. So thank you again. So we decided we'd go ahead and start taking a look at this Tektronix 465 that our friend sent in to us. And you know, with any repairs, always the first thing you do is to go online and download the service manual. And the service manual is available for this unit. As you can see up here on the other monitor, I have the service manual there, so it'll be easy to get to. Now, I really like having paper service manuals on something like this because you're constantly flipping from one page to the other. You might go in and look at the power supply, and then you want to go and look at the board layout, and it helps when you got paper to do that with. But also, you know, we have 3 monitors here, so I can put different shots of the manual up on 3 different screens at one time. And you can also go in and take different snippets of the power supply, like this is the 8-volt rail of the supply and the 15-volt rail, and just print out those single sheets. This way you're not doing so much flipping back and forth. It just kind of helps to keep things you know, situated as you're going through the steps of the repair. And with any repair, you know, the first thing, do you look at the scope, give a visual inspection to see if you see anything that's burnt, cracked, broken, or whatever. And this has already been done to this particular unit by the previous owner. And like I said, he sent us a nice detailed letter of what's been done to it. But if you didn't have that type of information after you do your initial test, you can go ahead and start your troubleshooting process by starting with the power supply. and I have the little copy here of the main power supply. So we can go in and start checking those. You know, we'll start with the 120 volt rail. It's a 110 volt rail, 55 volt, 22, a 15 volt, our 5 volt, and our negative 8 volt rail. That's what we need to be concerned with. Since we've already know the condition of the scope, and I have checked the fuses, and the fuses are not blown, and it does have the correct fuses installed now. So we'll go ahead and power the scope up just to see what we have. Now if you know, unsure of the condition of it, you power it up. You need to power it up on a variable transformer with isolation, or some type of current limiting device. So I'm going to get the scope moved on the bench, and we'll go ahead and power it up and just take a look at the front. Okay, so the scope is plugged into some current limiting protection, and we'll go ahead and pull the power switch on. And as you see, we have nothing. No lights. I don't hear no fan running. Nothing. We'll hit beam find just to make sure. Nothing on the screen. No trace, no dot, no power lights, no nothing. So this tells me that there's a problem somewhere in the power supply. And you know, another good thing was there was no smoke, so we're pretty safe on that. So what we're going to do is go ahead and check out the power supply rails, find out which ones are working, which one is not. We can assume that we do have mains voltage coming in, but we do need to check for that to make sure that it is getting mains voltage. If you look here on the bottom, up in this area, this is your power supply, and this is your high voltage second. So low voltage power supplies, you'll see a ground loop here that you can attach to, and then you'll see several pins over here for checking our low voltage supply. So we'll go ahead and start checking and make sure that we do have voltage on this thing. I'm going to just go ahead and check and make sure we do have some mains voltage, and I'm going to go from one side of the fuse to the other side to make sure that AC voltage is present back here on the transformer. And we have about 121.3 volts. So we do have AC mains. I can turn it on now. And I do have power on the high side of the switch. So now that we know that, we can go ahead and start testing our low voltage power supplies. Okay, I'm going to start. I got our negative lead on the ground test point, and we should be able to come right here, and this is our 110. Let me go to DC voltage. This is our 110 volt rail, and we're at about 106.7. This is our plus 5 volt rail, and she's at 6 volts. Here we have our 55 volt rail and 47.4 volts. This is our plus 15 volt rail, 1.8 volts. And here is our minus 8 volt rail, and it's 0.4 volts. So that is wrong, and our 15 volt rail is definitely wrong. So now we know that we do have a problem in our negative 8 volt rail and in our positive 15 volt rail. It is possible that one rail is affecting the other. It may not be that both rails are down. If I remember correctly, this thing does have a circuit. If one power supply rail is failing, it can affect the other power supply rail. So once you've done this and you checked your voltages on those rails, you can always go up here to the bridge rectifiers and check your voltage off the bridge rectifiers and see if that's correct. And that'll tell you what is coming off the bridge rectifiers. The next thing you can do after you troubleshoot that is you can start isolating the supplies. It's lifting whatever's connected to it and going back and checking the supplies and see if you have full voltage. Then you can put a load on it, check, scope out the rail and look at the voltage and the ripple on it. So I think now that we know that our 15 volt and our minus 8 volt rails are not producing voltage. I think I said 4 volts on the 8 volt rail. It's actually 0.4 volts on the 8 volt rail. So it's less than a half a volt. So what I'm going to do, this is our 15 volt bridge rectifier, and this is our 8 volt bridge rectifier. So I'm going to go ahead and look at the AC voltage that's on these rectifiers and see if we can determine what they are. Get the voltmeter in the shop here. Power the unit back on. See if we can get down here and read this AC voltage. And the 8 volt rail, there's 12 volts of AC on that rectifier. Now we'll check our 15 volt rectifier, see how much AC is going to it. And we have 1.39 volts. So the input voltage, the AC input voltage to the 15 volt regulator rectifier is way low. We'll go ahead and look at this other rectifier while I'm here. It's 9 volts, that's our 5 volt rectifier, so it looks good. So I'm thinking there's a problem somewhere in this 15 volt rectifier. The next problem is getting this thing out of here, because it's very hard to get to the other side of the board without tearing this scope completely apart. So we're going to have to get a little creative to remove this rectifier. So I got the 15 volt bridge rectifier out, and to get it out I had to pull the capacitor that's right next to it. We lost one little circle over here on a ground lug on this side. It had so much solder in there that it just, you know, had to really heat it up to get that connection loose. And getting this out was a pain also. I was able to go in from the top side and desolder these 2 pins with the desoldering gun. However, we could not get to these 2 pins, so I had to take the soldering iron and go up under the bridge rectifier and heat these 2 traces up and slowly work this thing out until I was able to get some solder wick under there and get some of it out and keep working it up. I did lift this trace a little bit, but I can be able to use some heat glue and glue it back down. It'll be fine, no problems at all. But I was real interested in this two components. This is a 5500 microfarad at 30 volts DC, and I'm going to make sure it's discharged. And we'll take our peak atlas meter and give her a little test and see where she's at. Well, it has an ESR of 2.4 ohms, and it says in circuit leaky, so that is definitely a bad capacitor. So that's good to know that that capacitor is part of the problem. Now this bridge rectifier. I'm telling you, it was a pain to get that rectifier out of there. Let's see, we'll go to diode mode. And the rectifier checks okay. So it looks like the culprit was this capacitor. So now that we have that out, we can go back and check our AC voltage, which should have been the 2 center pins. Remember before, we weren't getting but about 2 volts. So we'll go back to AC. I'm going to come up here and check between the 2 AC secondaries of the transformer. I believe y'all can see the voltmeter there. Turn the main power on. Turn the power switch on. And let's see if we have any AC voltage. And we have 20 volts of AC. Alrighty, I think now we're getting somewhere. While I'm out here, I want to go ahead and check our 8 volt DC rail and see if that has changed any. Nope, still at 0.4 volts. I'm showing 15 volts on the end of the regulator. So if we go to the negative side of the bridge rectifier, and we got minus 0.4 volts. Probably the capacitor off of this rectifier has been replaced, but that doesn't mean anything. It doesn't mean that it hasn't gone bad again. So we'll have to pull that out and check it. It looks like I need to get some capacitors. This is an old Mallory capacitor, as you can see. Alright. Okay, I got the capacitor replaced, and I made up this temporary 4-way bridge rectifier. It's a little hard getting this one in and out. It's kind of large. It's not the same size as the other 3. I've got some of these in a drawer somewhere. I just have to find them. But I wanted to go ahead and just test this out, so I made up this little small bridge rectifier. Not the prettiest thing, but you know, it works okay for testing. I'll get the voltmeter in the shot. Make sure there's no glare on it. Power the unit back up. We'll go to ground. Let's see what we got on the output. Go back to DC. And we're showing -3 volts. Okay, and across the rectifier we now have 21 volts. So there's still something that's drawing that down. Let's check our AC side of the rectifier now. 20.7 volts. So at least we have AC voltage there. I think the cap was knocking the pulling the AC down. If we follow out the positive side of the rectifier, goes around here to the cap and it snakes all the way around to this big transistor here. So our next task is to check this transistor. So, you know, we checked the voltage and we got 20 volts right down here to the collector of Q1546, which is a power transistor. I pulled the old transistor out. It's cracked on the back and the legs are a little loose. We'll check it out with the old component tester and see what this thing says about this. Now this is emitter collector base, so we should be able to read if this transistor is any good or not. And as you can see, something sure isn't working right. It's showing it from pin 1 to 2 as a diode, so that is definitely wrong. So we know this transistor is bad. It has a Motorola part number on it of a M352, and it also has, look at that, one leg just fell off. Also has the Tektronix part number, which is 151-0349-00. I've gone online, I've looked, and I'm finding these anywhere from $6 to $30 each. I've dug around in my power transistor collection here, and out of all these transistors I found an M352, and it is labeled MJE3055, and looking this up, it has the exact same pinout as our original Tektronix part number. So we'll pop this in and give this thing a go. Okay, so I ever so carefully bent the legs, got the transistor mounted in place, and you have to be careful bending. These are thick legs, and you can break the leg out of the body if you're not careful. This being the only one I had, I definitely did not want to break it. I'm going to go ahead and get it soldered in, and we see what we get. Alright, I didn't notice that when I removed the big filter cap, these 3 ground lugs are on different circuits, and it's grounded through the capacitor to make up the complete loop. So I lost some grounds. I lost ground on the bridge rectifier and lost ground to the main ground loop. So I had to add a couple of jumper wires, and all this is temporary just to get you know, the thing tested. Once everything is back to a working stage, then we can go and start replacing the old components with more original style components that will fix everything, like, you know, like the bridge rectifier and some of the caps and stuff. But we'll get that fixed. So we're going to turn the power on. Let's see, I believe you can see the voltmeter in the screen. We're going to come up and check our 15 volt rail again. Aha, 14.96 volts. So we are back. Well, we have our 15 volt rail back. I'll check the minus 8 volt rail, and it's at minus 7.96. So as you can see, like I said before, the 15 volt rail was affecting the negative 8 volt rail. Now we still don't have anything going on the front panel. So we're going to go back through now and look at the rails again. We'll come down here to the 110 volt rail. I've got the voltmeter out of the shot, sorry about that. Okay, 110 volt rail is 110 volts. 55 volt rail is 54.7. The 5 volt rail is minus 272.3 millivolts. So we do not have a 5 volt rail. So now let's go ahead, time to troubleshoot the 5 volt rail. So you can see without the 5 volt rail we still don't have nothing on the front illuminating. So what I'm going to do, just for curiosity, I'm going to take our little DC power supply, constant current, constant voltage, and I got it set for 5 volts, and we're going to connect this up and see if we get any lights at all come on, to see if anything happens. I do hear the fan running now, so fixing the 15 volt rail and the negative 8 volt rail has at least brought the fan up. But I would like to see just how bad a shape the 5 volt rail is going to be. So we're going to just inject 5 volts into it. And I don't know if you can see it or not. The light on channel 1 is on. I flip it to channel 2 and that light comes on. You can see our light over here come on. I don't see any intensity, but that bulb could be burnt out. Heating beam film does not bring up a trace. Still no trace on the scope, but at least we do have some life is starting to come back in it. So we'll go ahead and troubleshoot that 5 volt rail. Okay, this is the 5 volt rail, and we come off of CR 1551, which is our full bridge rectifier with a capacitor across the ground. And the positive side we should have 9.8 volts. And this goes down to Q1556, and it looks like some type of dual transistor. but we should have plus 5 volts on the emitter and about plus 6.7 on the collector. So we need to check this out and see what's going on here. If this is dead, we need to come here to R15, I believe it's 1558. It's 1.2 ohm, and pull this and see if this comes back to life. If not, then this is going to be dead. So Q1556 is right here. And whenever you're working on these, keep this cover in place, wanting high voltage. Do not remove this while you're working on the low voltage supply. There is another power transistor under here, but you know, keep this cover on until you really have to go into it, because it's about 2450 volts negative DC current, DC voltage under that case, and that makes for a nasty day if you come across it. Okay, we'll go ahead and check those voltages on Q1556 and on our collector. Let's see, it does help to turn the power back on. But on our collector we have 11.1 volts on the base. We remember we're supposed to be 6.7 volts, and we're at 11 volts. And on the emitter we're in the millivolt range. Alright, so let's go on to the next step. Okay, I'll remove the resistor here on one end, as you can see, right here. So now we can go back and test the voltages and see if anything changes. Turn the power back on. Connect our ground back up. Turn the switch on. Again from the emitter. Put it back on voltage. Alright, we'll start with the collector at 10 volts. The base is still at 10 volts. And the emitter is at 7 volts. So this is telling me that we have something pulling this line down to ground, cause the 5 volt rail is working. It's a little high, but you know, there's no load on it, so it's good that that little transistor here is not bad, because I doubt I'll have one of those. And it could be that when it gets a load on it, it will drop. Another thing I have to do is get me a constant current dummy load. I do not have one. I had a homemade one and it's in really bad shape. It's so old, and I really don't want to build another one. I'm going to go ahead and buy one that'll get the job done. I might go to Banggood and see what they can send me for free. You know, 5 volt rails showing 8 volts. So now we need to go to the other side of the circuit and check out and see what's going on. Okay, I have it set to ohms, and we'll check here at our emitter. We can see we have an open circuit. If I come to where I pulled the resistor out on this pad, and we'll check from there to ground. Yep, that's a dead short. As you can see, all zeros. So we definitely have a dead short on the other side of this resistor to ground. So I'm looking at this circuit here and trying to figure out what's going wrong in it. You know, we got 11 volts across the 2 pins of the transistor. So what in between there could be causing this? And the first thing that comes to my mind is this Q1558. That could be very suspect right there. So let's pour that out and take a look at it. Now we see Q1558 is right here, and it is a metal transistor, and it's probably just a general purpose transistor like a 2N2222 or something. Make sure everything is shut down, and we'll reach in and pour this. Like I said, one good thing about this, a lot of these components are socketed. I don't want to focus. And it is a 2N2222. Go to the parts bin and grab one. Get the legs bent right. That should be emitter base collector. I have to move the light down here so I can see these little holes. Someone's mentioned that my chair makes a lot of noise in one of my other videos. I do not sit in a chair. And what makes all that noise is this magnifying light here that I need to put some silicone spray on. And as you can see, my workbenches here in the shop are waist high, so I do not sit down and do repair. I like standing up. It feels more productive. You get set down, you get comfortable, and you get sleepy, and that's when bad things can happen. Alright, we got that 2N2222 replaced. Cut the AC mains on. We'll turn the power switch on. And I can already tell you good news to start with. We have lights on the front of the unit. We come here and check our 5-volt rail. You can see we are at 5 volts now. So that makes a world of difference. That was simple to fix and troubleshoot. But it's another bad component. Well, we're back on the front panel. You can see we have channel 1 light on. When we go to channel 2, you can see the channel 2 volts per division lights up. We have a light over here running. I'll press the beam fine, and we have no trace. Make sure the intensity's cut up. That knob is very, very hard to turn. Focus knob turns good. I still don't see no illumination here. Like I said, it's a good chance that the lamps in this is burnt out. That is a common problem with these scopes. So we'll probably be replacing them with some good quality LEDs. But yeah, we still have no trace. Back in the back, I've noticed that this fuse has blown again, and I believe it's F1419. And usually if it blows, that means there's a cap somewhere down the line that has shorted. And if we look over here on this side, you notice I have the high voltage exposed. Now make sure your scope is off, not plugged in, no power, because this is dangerous voltage over here. And over here is C, I think it's 1419. I have to look back on the schematic. This video is already getting kind of long, and I'm running short on time, so I want to go ahead and finish it up right quickly. But there's a tantalum cap that's normally over here, and I see it has been replaced. And let me zoom on over here. And you see it's been replaced with a different type of tantalum cap. And I expect that cap is shorted. So we're going to pull that out and drop electrolytic in there and see if we get any trace on the screen. Okay, all I have was a 50 axle lead, so I went ahead and mounted that in there for right now, and I'll dig through my drawer and find my other caps later on and get that replaced to an original cap. I'm going to just use electrolytic anyway. I'm not going to put a tantalum back in it. But we're going to go ahead and turn the mains on. Then pull the power switch. And I went ahead and replaced the fuse. 1.5 amp. Fuse did not blow. Scope is on. And we're seeing a dot on the screen. I'm able to move it vertically. I can move it horizontally. But we have no sweep. So that's another thing that we're going to have to troubleshoot. But I want to see now if we have any deflection on the trace. So I'm going to plug a probe in, and I already saw it wiggle. So all I'm going to do is just take my finger and put on it. And as you can see, it is seeing the you know, just a regular signal. There is no sweep at all. So we have able to make quite a bit of progress on this scope today. And I've got to get some new capacitors ordered. There's a bunch of other capacitors in here, a bunch of tantalums in here. I see there's some it's like 0.001s in the power supply that are kind of black and dirty looking. We need to go ahead and replace those also. I'll get some new regulators ordered because I want to go ahead and replace all these, not regulators but rectifiers. Go ahead and replace all of them, get the correct bridge rectifier back installed, and we'll do all that in part 2 of this video. Move the camera down. I know it kind of looks a little funky right there, but I turn the intensity down a little bit and get rid of that dot. You can see that's a nice pretty trace. It focuses out real good. Well, not actually a trace, but a line there, a dot. Looks real good, and we can see that the probe calibrator is working. That intensity knob is a little funky, but you can see we do have the dot there, and we know the calibrator is working. So again, we made a lot of progress, and I just got to get some stuff ordered, and in part 2 we'll go ahead and troubleshoot the sweep circuit and get that up and running, and then we'll go through and just do a general maintenance and alignment, and then in another video we'll do some testing and stuff with it. But it's good to see that this Tektronix 465 wasn't hard to bring back to life. At least it has a heartbeat now. So yeah, I think we'll be real good on it. Anyway, hope you enjoyed it. I know it's kind of in and out on some of the things, but hey, that thing will be working before long, and we'll have this old 465 up here on the bench to be able to use it, and hope to get many years of service out of it. Anyway, thanks for watching. I'll leave links down below to the website if you want to discuss this further. I'll get this on the website also. So until the next video, we'll see you then. Bye now.